Alright, let's do question number 8.
Because in these all the particular hemisphere was not given.
Alright, yes, so question number 8.
So I tried solving for both of them, like plotted northern and then in parallel southern hemisphere, and then was going through it. So in like this, in few of the question I spotted now it's not possible in the southern hemisphere. It is possible only in the northern hemisphere.
Why? Because you drew both.
Again, I want.
And you recognize the angles to be off on the values, and you see, okay, this cannot happen.
Like this, but I drew.
Yeah, correct. That's a good technique. But let's find out something that is much more easier, so you can quickly find which is the hemisphere, right? That's what I'm trying to say. All right. Question number 8. Great circle bearing from A to B. So great circle bearing from A to B is how much?
GCAB is 060 degree.
60 degrees true.
Yes.
Yeah.
And rhumb line bearing BA, RLBA.
It is from B to A.
It is from B to A is 250 degrees.
Okay.
Find the great circle bearing from B to A, GCBA.
From B to A. Alright. So here you are given the rhumb line track from B to A, rhumb line and great circle track from A to B. You have to find out the great circle track from B to A. Alright. So the hemisphere as such is not given in this question. So you have drawn both the hemispheres and you kind of checked, right? So let's assume this to be northern hemisphere, right? Or we can even assume this to be the southern hemisphere. Let's see the difference, what is happening here. North pole, south pole. This is the equator. Equator. So great circle track from A to B is 60, which means if you look at the true direction system, north, south,
just going northeasterly,
east, west. Yes, it's northeasterly, correct. So 60 is somewhere here, right? It's from A to B. The center is always the from point, and therefore the B is somewhere around here, right? And this angle measured from the true north is what is given as 60 degrees. So if I take a line that's parallel all the way, and if I draw it here, a straight line that is drawn on the Lambert's is considered to be, is assumed to be a great circle track. And similarly, we can draw something parallel like this as well, both these lines. And let's mark the points here. This is point alpha, and this is black. Right? Let's mark the angle that is given in the question. Great circle track from A to B.
To B is 060 degree.
Degrees true. Alright. Now, you asked a rhumb line bearing from B to A. So I have drawn a rhumb line now. That's where difference comes.
Yeah.
So the rhumb line, northern hemisphere, is going to be towards the south of great circle, and in southern hemisphere is going to be towards the north of great circle, or it is practically convex to the equator, right? So let's draw the rhumb line here. It's going to convex to equator or convex to equator.
Convex to equator.
Rhumb line. Right? Given rhumb line track from B to A.
To A.
Right? So from B is the point of reference is from B to A, local meridian at B, clockwise.
Yes.
Which is
250 degrees.
250 degrees true. Over here, you can see it is again from the local meridian of B, clockwise, which is 250 degrees true. Right? Now, the whole idea is you are finding it difficult to. So look at these two figures. You will find it difficult to compare these two angles primarily because one angle is at point A and other angle is at point B. If you can take this angle, great circle track to point B, or if you can take the rhumb line track back to point A, then now you have two angles at the same point, and then you will be able to compare and identify the hemispheres. Right? That's exactly what we just did. So what I'm trying to do is I'm trying to take this rhumb line track here because converting rhumb line tracks is easier because it's just the same. Right? So what is the rhumb line track when I take it all the way here?
It is again 250
It's again 250. Right? And therefore what is going to be this rhumb line track? Till here is 250 minus 180.
Minus 180.
Right? That is 50 degrees. Right? 180 plus 50. So 70?
Yeah.
Oh, sorry, yes, my bad. 70 degrees, yes. What about here? I can take the same run track all the way here, again from the local meridian, clockwise.
Yes.
Right? This is the run track. Now, what is the run track in the reverse direction from A to B? This is 250. So 250 minus 180, this angle, small angle is going to be 70. And this is how you realize that this cannot happen. Because this larger angle is 60 and smaller angle is 70. Therefore, it is not possible. Right? Therefore, this is not the hemisphere. The actual hemisphere is northern hemisphere. Now you see here, what if you can do what I just did here mentally? And that's going to help you find the hemisphere quicker. You see, you have the great circle track at A, that's from A as 60, and run plane track from B as 250. If run plane track from B to A is 250, what is the run plane track from A to B? That's very easy because it's just 250 minus 180. That is not the case with great circles. Great circles you have to apply convergency, all those things are there. Run plane is very easy to do that. Just 250 minus 180, you'll automatically get this as 70 degrees. Now you see, great circle track from A to B is 60, run plane track from A to B is 70. For this to happen, your run plane has to go below great circle.
Yes.
And that happens only in the northern hemisphere. Right? So instead of drawing the diagrams, you can actually find out using this technique.
Yes. Best.
Right? If they had given you two great circle tracks, then the method which I told you yesterday you can use. You add them, you get more than 180. You subtract them, you get less than 180. Add them, you get exactly 180. They are on the equator. So you can use it like that. That's only when you have both the great circles in place. And since you cannot find both the great circles straight here, in that case you can identify the hemispheres by looking into this. Just make AB, BA, AB. So you can compare both ABs, great circle from A to B and run plane from A to B. This conversion is easier. And then you can compare it.
Yes.
Alright? You're asked to find a great circle track from B to A.
Yeah.
This is on the hemisphere. So great circle track from B, from is the point of reference. B to A is clockwise all the way up till here. Right?
Yeah.
Now what does this help you? The great circle track being 60 and run plane track being 70, what do you get from this?
The conversion angle.
That's the conversion angle. How much? It is 10 degrees. Right? Again, two same points. The 2 points are by the same tracks. Therefore, this is also going to be 10 degrees. The whole great run plane track is 250. Therefore, great circle track will
Plus
be
10.
plus 10, which is 260 degrees.
260 degrees. Correct.
Degrees 2. That is what is asked. What else is asked in the question?
Yeah, same only.
Anything
Great
else?
circle bearing from B to A.
That's all. So you can identify the hemispheres like this. That's easier, right? Or even doing this is also fine. There's nothing wrong. You can still find out, right? Perfect.
But the technique which you told, that was I think much more easy.
Yeah. Yes.
To understand immediately. We can just spot it with the angles only that okay, this won't be possible.
Yeah.
This
Correct.
is possible. This won't be possible.
Yes. Southern hemisphere, the ground plane tracks are lesser than great circle tracks. So that's how this is the equator. This is the northern hemisphere, southern hemisphere. And if you draw the great circle track, straight line. These are the great circle tracks.
Yeah.
Now if you know run plane tracks here, that's where the difference happens. You can see run plane track is towards the equator here. Here also it is towards the equator. Now if you compare the great circle tracks and run plane tracks here, the great circle track is lesser than run plane track in the northern hemisphere. Right? So you can see run plane track is more than the corresponding great circle track.
Right circle. Similarly, this side also it's.
Yeah. Now in that side also, when you consider, be very careful here. Look at the great circle track here.
Is more.
That is so much. What about run plane track?
It's less.
Is less. So you should know the direction which you are actually looking at. If it's more towards is in between 0 and 180 that hemisphere, then rumpline track has to be more for it to be northern hemisphere. If it's the opposite side, it has to be less. So that you have to have a small idea about the orientation of the angles to find that out. Right? Similarly here you can see the rumpline tracks are actually smaller than great circle tracks in the easterly directions, and the rumpline track is more than the great circle tracks in the westerly direction. So rumpline tracks are more here, right? So but if you take the initial point, both easterly, you can say that rumpline track is less than great circle track easterly. So if you can remember this, then it's just the opposite, the other way around. Here rumpline track is actually less than great circle track. Rumpline track is less than, more than great circle.
Greater than.
Great circle track, yes. Just the reverse. Okay. What about at the equator? 2 points on the equator. The great circle track is equal to rumpline track. So it's one on top of the other, right? So it is equal.
Rumpline equal to great.